Okay, welcome to Algebra 2, notes for section 7.1, and this is 3/4 of the way. It's actually page 3 of 4 pages, so 3/4 of the way through the notes. Now, what we're going to look here is at roots, like square roots and cube roots and so forth, of variable expressions with exponents on them. So in the first example here, you can see that a has an exponent on it of n, and that we're taking the nth root of that. Okay? So in general, taking an nth power, maybe a third power, for example, and then taking the cube root, those are canceling actions. So you're going to get your number back. You just get a back. To illustrate that, I'm going to give you a cube root here. The cube root of 5 cubed would just be the cube root of 125. That's 5 times 5 times 5. And that gives you your 5 back. So you can see that if a was 5 here, we'd get it right back. All right, so let's do another example here, but this time we're going to use an even index, and things change when you're using an even index. So let me give you an example here where you have an even number out there, and the one I'm going to pick is the one that's actually blank. I'm going to use a square root. So a square root looks like this. You can think of there being a little index of 2 out there if it helps you. And then I'm going to show you that if you have a negative value for a, and after all, we don't know what a is, and you square it, it doesn't actually give that a value back. You're going to get square root of 9 here, and you don't need the little 2, but it helps you to see this here, and that would be positive 3. So we don't actually get, sorry about that, we don't actually get a back, we get the positive version of a back. So what happens in a case like that is you need to ensure that you're getting the positive version back. And the way you do that is you put absolute value bars around it. So with an even index, that would be like square root and fourth root. You need to put the bars, the absolute value bars on that variable. The other thing is that to do this, you have to know that an exponent on the variable gets divided by the index. So I'll illustrate that with just a simpler example. Let me kind of make a little box here, and I'll show you what I'm talking about. If you have x to the fourth and you're squaring it, those exponents get multiplied together, or you can think of it as x to the fourth times x to the fourth. I'll do it a different way here. And you get x times x times x times x, that's the first one, times the same thing in the back, x to the fourth looks like that, and you end up with x to the eighth. So we squared it to get that. If you took the square root, you would get this answer here. So now I'm going to erase that and show you what that would look like if I just wrote it straight. The square root of x to the eighth. Let me put the index on there to make this more obvious, is x to the fourth. And you can see that if you just take your old exponent and divide it by the index number, you'll get the new exponent. All right, so we're going to combine these ideas here and figure out a couple, 2 or 3 problems here. Okay, so with the odd index out here, it's like this first example up here. You don't need the bars. So odd index, cube root example here, does not need the bars. And 15 divided by 3 is 5. So there's your absolute value, there's your cube root. Now to show this, we're going to multiply something by itself 3 times, and namely the x to the fifth. And you'll see that this equals x to the 15th. So the first one would look like this if you wrote it out. So would the next one. And the last one. And you've got 15 x's all multiplied times each other. So that's x to the 15th. All right, so let me get rid of that. All right, the next 2 problems have an even index. And because, here's the reason why we put these bars in there. There's a 2 there that's not written. We're going to have to put absolute value bars in here to ensure that our answer is the positive version of it. When you have an even index, there's 2 answers, but that radical sign always is the positive version of it. Okay, so we'll take this another stage here after we get these written down. The fourth root of 81 is 3. You can type 4 math 5 on your graphing calculator, and then 81, and it'll pop up with 3. And the other way to confirm this is 3 times 3 times 3 times 3. Then you take your old exponent and divide it by the index to get your new exponent. Okay, now we're going to come back to this problem in a minute. Let's do the square root down below. Square root 25 is 5. And then when you take the old exponent, divide it by the index, you get a new exponent of 4. Okay, so let's go back to example 13. This number here is already positive. In other words, putting the bars on it to ensure that it's positive is a waste of time. In other words, 3 is already a positive number, so you don't need the absolute value bars around that part of it. The same would apply to this 5. And for a different reason, this x to the 4th power is guaranteed to be a positive number. And you can think about it this way. If you had a positive times itself 4 times in a row, that's one possibility, and that would turn out to be positive. And likewise, when you have a negative multiplied by itself 4 times in a row, you still get a positive. So no matter what, that x to the 4th is going to be a positive number, and because of that, you don't need bars around either part of that bottom example. But in the one above, where it's got that x to the 3rd, we don't know whether it's positive times positive times positive, or negative times negative times negative. We don't know the value of x. And as a consequence, we don't know whether our answer is positive or negative, but radicals require that we have that answer. So what we're going to do here is just ensure that that part stays positive by leaving the bars on it. Okay, here's a shortcut. If your index is even and the exponent at the back is odd, that's the only situation that you need bars around it. So even in the front door, odd exponent out the back, you need the bars. All right, so let me show you what that looks like at the bottom of this page. I've scrolled down there, and let me zoom in a little bit. So we have 3 cases over here where we have an odd index. And that means we don't need bars on any of them. So x to the 21st power, cube root, would be x to the 7th. And the 7 is simply 21 divided by 3. The next one is going to be 6th power, and we got that by taking 30 divided by 5 to get the new exponent. And then the cube root of 8 is just negative 2. And if you take this power and divide it by that index, you get a 1. So it's going to be x to the 1st power, or just leave it as x. Okay, all the other ones on the right-hand side have even indices. The middle one is blank, which means you're dealing with an index of 2. So 4th root, 2nd root, which we call a square root, and finally down here a 6th root. Okay, so you need bars. Whether you drop them later is a different story. You need the bars. Okay, the first one gives x to the 2nd power. 4 is the old exponent. I'm sorry, 8 is the old exponent, divided by 4 to get your new exponent. Now, because x squared is positive even when x is negative, we don't need the bars on it. Okay, problem 18. Square root of 25 is 5, positive 5. And then 14th power divided by the invisible 2 that's out there would give 7th power. And of the two expressions, the 5 is already positive, so we'll pull it outside the bars because it's already positive. But the x to the 7th, we have to keep the bars around it to make sure it's positive. Think about a 7th power with a negative number. You'd have a negative times a negative times a negative times a negative times 3 more. And these would pair off to give a positive. These would pair off to give a positive. These would pair off to give a positive. And we have positive times positive times positive times negative, which would be negative. And as a consequence, if we want the positive answer, you got to make sure that happens by leaving those bars on that one. And once again, you see that it's even in the front door, odd exponent at the back. That's when you need those bars in the final answer. Okay, the sixth root of 729. You can type, if you've got a graphing calculator, a TI-84, you're going to type 6 math 5 729. Should give you 3. Okay, so 3, and then x to the 24 divided by 6 would be 4. And both of those are going to represent positive numbers. The 3, because it's just a positive number. But this x to the 4th, if you think of all positives, like positive times positive times positive times positive, or even all negatives, and I'll show you that one, negative times negative times negative times negative. Well, they pair up, and those give a positive, and these give a positive. So you'd get a positive answer even if you used a negative value for x. And as a consequence, we don't need the bars around that part. It's guaranteed to be positive anyways. So it's only when it's even index and an odd exponent out the back that you need that part of the expression inside the absolute value bars. And there's another video for page 4.